Hello, everyone. Thank you for joining today's roundtable discussion on technological innovations, the impact of AI and machine learning on the energy industry. I'm Matt Chester of Chester Energy and Policy, and I'll be moderating today's session. And before I introduce our panel, I do want to thank Vedeni Energy and Saviant Consulting for their role in putting this session together. But now the real stars. We've got a fantastic panel lined up for you with experts from Aypa Power, Advantech, 1898 & Co., Easy Metering, and Saviant Consulting. Each of our panelists brings a unique perspective on how AI and machine learning are driving advancements across the energy sector, from energy storage management to edge computing and beyond. So let me start by introducing our panelists. And first we have Swaraj Jammalamadaka from Aypa Power, a recognized leader in the energy and utilities industry, currently serving as Aypa's Chief Technology Officer. Thanks for joining us today, Swaraj.
Glad to be here, Matt. Thanks.
Next, allow me to introduce Scott Burk from Advantech, a seasoned expert in critical communication infrastructure and a vertical sales energy specialist focused on edge computing and edge computing solutions for the energy market. Welcome, Scott.
Hey, thank you, Matt.
Next, we have Carol Bogacz from 1898 & Co., who brings over 29 years of experience in analytics, leading teams and delivering strategic offerings, and currently serving on the board of the Utility Analytics Institute. Thank you for being here, Carol.
Thanks, Matt. It's a pleasure. Looking forward to it.
Me too. And next we have Kevin Santana from Easy Metering. Kevin is an AI data scientist developing machine learning models to detect losses and anomalies across the energy industry. Hi, Kevin.
Hi, everyone. It's a pleasure to be here.
We're happy to have you here. And last but not least, we have Jignesh Shah from Saviant Consulting. Jignesh drives the global technical programs at Saviant, and he transforms businesses' unique problems into technical solutions by consulting them on various technologies. And his expertise lies across data analytics, AI, IoT, and machine learning. And thanks for being here, Jignesh.
Thanks, Matt. Glad to be here.
Great. So let's kick it off. And in today's roundtable, we're going to dive into 4 key areas at the intersection of AI and energy that demonstrate both the challenges and the opportunities. Those 4 pillars that our panel is ready to speak on are energy storage management, edge computing, AI and ML adoption in energy, and innovation in AI-driven R&D. Each section will begin with an opening question that I'm going to direct at the panelist who works directly in that field. But then after that, I'll open it up to be followed with some additional questions that I invite any of our panelists to jump in on. So let's get into this engaging conversation. And our first section is focused on energy storage management with Aypa Power. So to kick things off, Swaraj, I'd like to ask you the following. What are the top challenges you see in the world of energy storage management that your company is focused on now and in the coming years?
Yeah, thanks, Matt. Appreciate that. So the key aspects is twofold, actually. One is educating the customer and keeping up with the chemistry and the technological changes. So obviously, energy storage has come a long way in the last 6 to 7 years. Most folks only see the cost improvements, but the technology is a lot more safer. It's a lot more predictable. It's a lot more manageable. At the same time, it can provide a ton more of services than what it could many years ago. So it's hard to keep up with those trends and trying to find the value proposition for the customer in general. And most of the buyers of energy storage today are typical traditional utilities who have been used to buying traditional power plants, and took a long while for them to move on from traditional power plants to basically sustainable sources of energy. And now with battery storage, which looks like a combination of both sustainable and dispatchable, it requires some sophisticated tools to explain the value proposition to the customer. And this is where a lot of machine learning, all the way from basic machine learning to identify site selection on why a certain site is valuable to a certain customer, and all the way to once energy storage is built, how do you forecast intermittent generation? How do you figure out when to dispatch it? So that's the more significant deep learning aspects of AI that comes into play, where we are forecasting the next day, the next hour, the next 5 minutes. How does that look like? How do we optimize and dispatch and manage state of charge of the system? So in a nutshell, I think it's given us the tool set to basically find value on the customer portfolio. So be it a utility, a state, or any kind of load serving portfolios, they can look at where storage plays and what is the value to the end customer. And advanced analytics enables us to actually do that.
Yeah, it's interesting. And obviously, from the AI perspective, it's not just about putting that next to energy storage for the sake of doing it, but it's enabling energy storage to reduce operational costs, enhance grid resilience, things like that. So Swaraj or any of our other panelists now, I'm curious if you can share any examples of specific use cases where that's being done today.
Yeah, I can quickly start off. I think there are a couple of unique problems that are not only unique to geographies, but are also unique to how power consumption has changed over the last many years, right? So in the late 70s to early 90s, it was mostly industrial-based growth that came through iron smelting furnaces and metal smelters that basically were the major increase in load profiles. Population densities grew, but commercial load was mostly the one that was the main price of the demand. And now in the last 5 years, you see data center needs, processing, compute, storage as becoming the more critical areas of energy storage or energy needs within the system. I'm sorry, I lost my chain of thought over there. Can you repeat your question?
Yeah, just the idea of use cases today where.
Oh yeah, sorry. Yeah. So certain use cases where energy storage can come is when people are looking for investments to serve certain load growth in their area. Most of them might be looking for some capacity needs. So they need infrastructure that is available and dispatchable, but it's not needed for the entire duration. It's not expected to run for a long time, like peaking gas plants. You're investing in peaking gas plants that probably operate 2 to 3% in a year when during the summer. So, and for a few hours every day to maintain the peak demand. So storage fills that need where it can come in and actually basically manage that peak for you, and you don't have to invest in significant capex to come in and be there for the entire year. So storage fills that need. Along with when infrastructure expands, you need to coordinate with certain transmission infrastructure to basically deliver that. And transmission is something that takes quite a bit of time. And storage is something that gets online pretty quickly. So storage can also be a transmission or infrastructure deferral in many of the areas which are required to basically serve load. You're either looking at a substation expansion or a new line coming in. In many instances, storage can fill the gap in to basically solve the infrastructure challenge. One of the edge case use cases I've seen is actually you can use storage for wildfire management on transmission lines. So transmission lines are made up of a combination of metals, and when there is heat passing across it, it sags and it hits some kind of landmark or a landscape like a tree or something, and then it can short and cause a fire. Well, storage can help relieve and manage the flow on those lines to basically make sure that during peak heat times your infrastructure is not as loaded as it was previously, so you can reliably, safely operate. So that's one edge use case that I'm seeing right now emerge, as storage can be like it can relieve your overloaded transmission.
I'd say one of the edge cases that I've seen with battery storage, and I apologize, that I've seen is with the the Type 3 EV charging stations. It's playing havoc. Not just with the large IOUs, but the small municipalities are having an issue because each time a Type 3 comes online, that's like a brand new McDonald's coming online for 20 minutes. And the large IOUs aren't even designed for this kind of demand all the time. So we're going to see more battery energy storage put into play. Certainly going to need more in the rural markets to accommodate the need as more people move out of the cities, want EV chargers everywhere, not just off the main freeway, but further into the rural markets. So we're seeing it there as well.
Carol, I saw you agreeing with Scott there. Did you have anything to add on this conversation?
No, I agree. And then I think I was just smiling at what Scott was saying, because we also, the load, right? So the infrastructure, is it ready for the load that Scott was talking about, with AI, with EVs, with data centers? So that's just what I was nodding in agreement. How are we going to handle that?
Yeah, that's definitely one of the big picture questions that we see keep coming up, and so that is a good segue into the bigger picture topic we're here to talk about today, which is AI and machine learning. So I guess Swaraj, I'll pull you back in to talk about, well, what are the ways that each of these use cases and challenges that energy storage is playing a key role in? How is AI and machine learning enhancing that or changing the way that we can think about addressing those challenges?
Yeah, the amount of data crunching that needs to happen to figure out how to basically manage intermittent resources of generation, like wind and solar, along with balancing them onto the system. And we have very complex energy markets across the United States. So to make those markets really efficient and operate and use the best resources or the least cost resources that are there, you definitely need very complex machine learning models that are not only learning in real time, but also training themselves, because the energy markets are a moving snapshot, right? Like what it was last year and what it's going to be the next 2 or 3 years, that moving snapshot keeps changing. So that's where machine learning is playing a role in basically implementing and training the models, which can not only forecast weather, but they can forecast weather-dependent generation on what those output would look like and where storage would need to fill the gap in. And there's a bunch of services rather than just balancing it. So it's ancillary services, regulation required to the market. And also on the load side, obviously, Scott talked about the demand side stuff, which needs to happen, where you are forecasting the demand and providing in real time what the demand needs are. But the major needs are coming on both sides. It's also coming on the demand side of things. It's also coming on the market side of things on a wholesale level. So that's where we're seeing AI play a major role. It's helping us forecast, it's helping us optimize and train models, which with human dispatchers and traders is almost not possible.
Yeah, absolutely. And Kevin, I kind of want to call on you there based on what Swaraj just said. As our kind of resident data scientist, are you seeing the same things in the use of AI when it comes to integrating energy storage into the type of models that you're working on?
Yeah, he's right, because energy data is complicated and it's depending of the user on the patterns the user have, on how they consume, on how they use the energy. These patterns will be different in every house, on every build, or every utility. So you have to use machine learning to do like a self-learning of individuals, using their own patterns to construct models for each individual, to detect the patterns for each one. So yeah, that's really good, right?
Excellent. Yeah, that's helpful. And again, I think what's also helpful as we talk about these high level ideas is to bring in the real world examples. So I'd love to again kind of prod if there are some real life examples where AI has been used to optimize energy storage systems, and maybe specifically extending equipment life without also increasing the maintenance costs that go with it. And Jignesh, I wonder if you're a good person to take a first crack at that question.
I think one of the use case we recently worked on for a small organization, the microgrid operations, right? Basically repurposing the used batteries and using them to store energy with solar and wind, basically renewable energy. Idea was to get all the systems in place, from the SCADA system, CAP server, and integrating a lot of third-party applications and selling a lot of stored energy to the grid. It required edge calculations, when to store, how much to store, and it definitely helped in making sure that maintenance costs are low. With the solution, it provides real-time as well as periodic reports. It definitely helped in making sure that some of their partners, automotive companies, right, and Renault, they are partners in that. They need to review the efficiency of the overall performance to invest more and see the value. Some of this machine learning and models really helped in making sure that there is a lot of data, as everyone said, but pretty complex data, like tons of text coming every 2 minutes, and to process it, and still figuring out what are the best time to store the energy, what are the best time to sell the energy to grid operators. I think this was a pretty good use case in making sure that immediate value is shown plus sustainability goals are achieved. So this I on top of my head, it was pretty good use case I encountered in last 6-8 months. But there are a lot of use cases, as everyone mentioned, and they are just going to blow up.
Yeah, well said. Any last thoughts on this topic before we shift to our session number 2?
I mean, I could add to a smaller battery storage system for residential use that we've seen, been part of. Part of it was to look at the consumer's footprint and identify usage throughout the day as you start tracking it for demand, understanding how much energy was being captured on the solar panels being trickled down to the batteries, and what could be given back to the utilities, as well as what should be stored for the consumer's needs, so that they weren't paying the high rates, at the time from the utilities for demand, but actually using their batteries. And then a tie into the weather. It's a simple application, but where this deployment was, it's on a Caribbean island, and we were looking at the weather and knowing, hey, there was a storm, there's going to be a cloudiness, or you're not going to be generating capturing energy off the solar panels for the next 4 or 5 days, therefore don't release anything back. So some simple things that you start building upon, and we'll see AI just expand that need. I mean, it's going to grow. It's all been started with machine learning, but AI becomes basically that enhancement, right? The 100-fold machine learning ability.
Yeah, and I've seen, at least in Texas, because of the market structure, a lot of people aggregating residential batteries at scale. Already seen virtualization in California, where they're operating them as virtual power plants. And we're not talking 100, 200, we're talking a couple thousand of them, which is interesting at scale. It probably becomes a market product of value. And we've seen that happen now in Texas. So without machine learning and significant deep learning tools, that kind of capability is absolutely impossible, because we're working through significantly different conditions to figure out how to optimize all these demand side resources. So definitely an exciting area.
Yeah, smart campuses, right? The sharing of multiple buildings, capturing energy, and sharing it to one battery source for use elsewhere or there on campus.
Yeah, no, it's a lot of exciting stuff here, and be more if we, as we shift gears and transition to our next section. What we're going to talk about is edge computing and IoT and how those are transforming the world of energy efficiency. And Scott, we're going to stay with you to start this conversation. And what I want to kick it off with is, what are the main customer demands when it comes to energy efficiency projects, and how have those requests and requirements evolved over time?
Yeah, we've seen, we started touching on this, obviously, in these previous conversations, but, we're seing it more out at the edge, there's an initiative by the DOE has stated a vast study on AI needs to be pushed all the way to the edge in order to achieve net zero carbon footprint by 2035. So we're seeing more of a demand out at the gateways, at the aggregation of the meters, for the Durham gateway, intelligence there, learning individual electrical footprints from the consumer and how to respond, like as far as demand comes in play with multiple EV charging demand coming on at once, maybe overriding the transformer. There's some initiatives happening there. This initiative with AI, though, it's very new. So a lot of it's just, hey, we're at the very beginning. Is the conversation going to be different a year from now? Certainly, because there's a lot more trials starting to happen where more power put into the consumer's hand with the smart meters, as Kevin's going to probably talk about with the metering effort there that we're seeing. We're seeing more meter companies looking for AI under the glass so that they can be more intelligent in usage inside the residential home, apartment, etc. And then, you start stepping out of there. As I mentioned, the gateways is big, but then also now the substations are changing as well. Not that the utility worries about energy efficiency at the substation, but there's some real drivers there where they're reducing the racks of equipment for central control, better security means as well. And AI is going to play into that as well.
Yeah, it's definitely some fast evolving progress taking place there, and so I do want to open up the conversation because I'm sure the edge computing, the IoT, in one way or the other, does touch the work that all of our panelists do. So the question I have to open it up to everybody is, how is edge computing transforming the real-time decision making that's taking place in energy management? And again, if we could tie it to some of the real world examples that you all are seeing, I think that would be really helpful.
Yeah, in my opinion, IoT is a lot more complex than storage because irrespective of chemistry of storage, you still have certain fundamentals on the device in general. But IoTs are like everything intelligent that is connected that you can dispatch or call or ping in for data and operate becomes a source of data. So it's extremely complex to have like digital twins that can simulate them. And basically, the piece of edge computing that becomes important is if your IoT devices are significantly energy intensive and you want them on reduced latency, then having that compute and storage closer to those becomes super important. And we've seen that a lot with very complex AI-based fault detection in manufacturing that's happening where they have very little tolerance for latency. And that's where you pretty much all these facilities might need their own data centers next door to process that because they don't have an appetite for low latency systems or delayed latency systems.
Kevin, I'm curious what you think. Scott brought up that the work that your organization is doing with the metering side. How are you seeing the transformation when it comes to energy management with these edge computing technologies?
Yeah, this edge computing definitely improve into the analytical world, right? Because you are not just doing some analysis in the cloud. Now you're going directly to the source of the data. So you have more granularity of the data. You're not like taking measure of every 15 minutes, every 30 minutes. You can have data of 2 minutes, 1 minute, even seconds. So you can make more instant decisions based on the demand of the person, right? And that's basically it, right? You don't have problems in the latency of giving the data to the cloud. You don't have problems of privacy of the data, sending a massive amount of data to the cloud. You are doing all in the edge, right? That's one advantage of the edge computing. And what now with the smart meters you are trying to do is that you are trying to implement machine learning algorithms to do like instant detections in the meter that you are just gonna send that alarm of the meter to the cloud to advise, oh, this matter is problems, it's happening something, right? And you're not sending all the information in time of that matter. Yeah, that's it. Yep.
Great.
I think
Yeah,
you
that's
see more, this edge intelligence and computes happening now as you start transitioning a utility from, the fossil fuels generation source of power, and then they have to start feeding in, solar and the wind farms and the ability to switch and know when to switch between those two sources and when to bring them on. You're seeing more AI adapted at that point as well. I mean, so it's not just, down at that consumer, but, the utilities themselves, or how to manage that so that they don't get into a problem with load shedding and the rolling blackouts that are, they're going to have to really fine tune how they integrate different sources of energy into it, and when to know when to actually bring fossil fuels back online to supplement demand.
Yeah, and I think that's a great point, and it speaks to the idea that these technologies, IoT, edge computing, it's certainly not a monolith, and it's not a static, oh, we implemented that, check mark, we don't have to think about it anymore. So, it leads me to my next question, which is, what are the advancements taking place in these areas, in IoT and edge computing, that might be better able to help meet those future energy efficiency targets? Where are these technologies going in the future?
I think a lot of it ends up being driven by cost, right? With the edge compute and, getting down to where it makes sense to deploy, right? Where it makes sense to build a meter with a GPU on it that's cost efficient and the payback's there, because the utilities have to adopt it, right? I mean, we all can see the benefits of it, but if it doesn't make financial sense, or they don't see a quick, return, then, it's slower to roll out. But, we're seeing the cost of hardware go down always. We see the cost of technology going down. So, there's always a spike in technology and price when it comes out, and then we always see it drive down. So you'll see changes happening here, right?
Yeah, my 2 cents
It can't
on
be
this
for free, though. It'll never be for free.
Swaraj, what were you going to say?
Yeah, a couple issues that we are seeing with edge in general are, at least the people that we're talking to, is like they're not really price sensitive to capex. The biggest problem right now has become power supply. Edge is close to population centers, or where real estate is a lot more competitive and complex, and getting infrastructure, especially power supply, has become one of the most biggest problems for these, because they're not small anymore. We're not talking 20, 50 megawatts. We're talking 300 to 400 megawatts on the edge side. And that's the biggest problem, is to get efficient sources of energy, or any source of energy beyond efficient, to actually get them to serve. And they're on a wait list right now. It can take anywhere from 2 years to 8 years to get connected. So that's the problem we've been hearing, that guys, we'll go anywhere we can get supply, but edge has to be closer to the population centers. Is from an infrastructure issue, that's what we are seeing on our side, and that's why we're seeing the hyperscalers, who are more like not latency sensitive, go more in remote areas where they can find land, infrastructure, and energy as the primary source for basically developing at hyperscale. But edge is still closer to where the demand is.
Yeah, thanks for that. And what I want to look at now is, how are the advancements in real-time IoT analytics enhancing usage, energy usage predictions, and grid performance, and where are we seeing advancements there, and what are the end results of that? And I think maybe Jignesh would be a good one to start with on that.
Yeah, I think there are a lot of use cases because of the real-time IoT analytics. There are smart city projects, especially in Middle East. A lot of smart city projects, smart building projects, which are kicking off at a large scale. One of the very interesting use case is in the utilities domain, where specifically on a water side, where because of the real-time computing available and the advancements in hardware processing, hardware capabilities, the leak detection, the faster leak detection is much easy now, and it prevents a huge financial burden, specifically in some of the Midwest areas in US where it is costly, where homes are huge. So 1 minute kind of latency is good enough to figure out what kind of leaks are there, faster prevention, real-time monitoring, real-time processing. They are high-frequency data. It can detect leaks, abnormal usage pretty quickly, and it can definitely, the system behind it at the source as well as in the cloud. There is a lot of compute power available to give a lot of insights to utility companies as well as to the end customers, which has a lot of value nowadays. So one of the interesting use case I could think in the utilities domain is on the water side, water grid side, water management side.
Mhm.
Excellent. Does anyone else have any last thoughts on this topic before we shift to section 3 of our talk? Awesome.
Good.
Awesome. Well, the next one's a good one, and we want to dive into AI and machine learning specifically being adopted across the energy sector. And Carol from 1898 and Co. I want to turn to you first for this section.
Sure.
In your experience and the clients you work with, can you speak to what maybe the most prominent barriers are to wider adoption of AI and machine learning tools in today's energy sector?
Absolutely. So, and we've all touched upon it and said it and kind of danced around it, right? But it's because it is a 4-letter word, right? It's data. See how I did that? But data quality and data availability, right? So Kevin talked about the models and we, as a data scientist, we love those models, right? That's the fun part. But the not so fun part is the cleansing of the data. Kevin's shaking his head because 80%, right, of our time. I mean, they told us that in school and we're like, oh yeah, no, I'm going to do those fancy models. But it's the data quality. I always tell my students, so I teach part-time as well, but it's the 5 V's. So we go back to the 5 V's of data, the velocity. So we've talked about it, the speed at which it comes in. You have to understand that, right? The volume, the amount of data. So do I have enough data of good quality coming in to answer the questions that the business is asking? The other one, the value of the data. The variety. So am I just looking at the same thing? But I have a lot of the same thing. But what's the variety of data? Because you're going to need a lot of different data to build the models that AI and ML are bringing, right? And then the veracity. That's just the data quality and the accuracy of the data. But the energy sector deals with vast amounts of data, right? So we want it to be good because we have sensitive data. Grid information, we've talked about customer data, we've talked about operational details. So the barrier is the data coming in, but then we've talked about the infrastructure, right? Some of our legacy infrastructure may not be equipped to collect that data. So Kevin will talk about that in the easy metering. We'll let him talk about that. But what about the second barrier would be the infrastructure. So are the meters out there collecting the data, right? Do we have the smart meters out there collecting? Are they collecting the right data? So even though they can do it, when we put them in there, did we equip them to bring in that data? When I say bring in the data, where are we bringing it in, right? So where are we landing the data, all the buzzwords, data lakes, data lake house, whatever you call it. Is there a central repository infrastructure in-house, in wherever it is, landed that is providing that single source of truth? right? Who's saying that that data is right? So is the data infrastructure in place for the utility to make the decisions that they need to on the data? Do people trust that data? So the third thing, and I've said it probably 3 times, is the people, right? So now we have the quality of the data, we have the data infrastructure. Is it coming in? Is there a single source of truth? And do I have the people in the organization around that data? And what does it mean for an organization to be data driven, right? In my mind, you have to have at the enterprise a strategy, right? Then the people and the culture supports the data strategy. Then the metrics, whatever we want to call them, KPIs, the metrics, but are we looking at each business unit has to be looking at the data and the metrics that support the overall strategy of the enterprise, the utility, the organization. And then the data management. So again, it's around the data quality, but once I bring it in and it's in-house and it's in that thing, who are the stewards of the data? So we call it data governance, data management, whatever you want to call it. Who's saying that, yes, that's the right data coming in at the right time and it looks good, right? And then the next pillar, if you will, tools and technology, right? So now we have, do my businesses have the tools they need to make those decisions, right? The last one, I call them analytics capabilities. Do I have the people with the skills needed to make those decisions, right? So I think, Scott, you touched on it, is what we're looking at now and how we're looking at it. It's not going to be the same even next year, right? So do my people have the skills they need to make the decisions? And so those are the pillars. So those are the 3. So it was the data quality, the infrastructure in place, and then the organization to support that. So in my mind, those are the 3 barriers of wider adoption of AI and ML.
Wonderful. That was terrific, Carol. Thanks for that. And Kevin, like Carol, I saw you agreeing a lot of the way there.
Yes.
So I'll pull you in to see if you had any follow-up thoughts to what Carol just shared.
Yeah, definitely data quality is essential for any company. It doesn't matter if you have the best model trained, right? That have the best metrics, but if your data isn't good, you will have bad results. So that's why every company should have a good data strategy to analyze what data they have, how they have it, and how they can use it. So yeah, definitely data is the basic, the pillar that every company should work on. And yeah, definitely. Yeah.
Isn't that also the visualization, right, of the data? It has to be in a format, has to be delivered to that end user operator. There's the check and balance, but it has to be displayed and given to them in a way that means something, because not everybody's going to be a data center, data scientist that's running the operations center, right? It's got to be given to them, visual, red charts, green charts,
Right.
Has to be given to them in ways that they can implement it and use that information for something and correct it.
Absolutely, Scott. And the visualizations. So sometimes, and I don't know if any of y'all have experienced this, but Scott, you brought up so you build that dashboard, right? And it's a beautiful dashboard, but how do you
use
get
it for?
that? Yeah. So how do you get the business units to take that dashboard to action, right? Mm-hmm. So there's the key, right? That bridge from insights to action, if you will. But yeah, dashboards are the key.
Yeah.
Thoughts, Scott? I'll let you chime back in.
No, I agree. And there's a lot of dashboards out there, but not all of them, do the same thing. And you got to really, work closely, with the data that you're gathering, but then you got to work closely who's going to display it and what you want to see, because you don't need to see everything, but you need to see, some key things. You have to know what your operations is doing. You have to know what the key events are for that drive maintenance, so that you can pull that information out of the data that you're collecting over, not one endpoint, but millions of endpoints. Yeah, not an easy task.
Not at all. Thank you.
And in terms of another way to look at how are these tools being used, one thing in the utility space specifically is that regulations are coming more and more to the utility world, whether that's reliability or in emergency management situations or in decarbonization. So I'm curious if there are ways that AI and machine learning are being used today to improve the ability of utilities to work towards compliance or even just demonstrate their compliance. Are those tools helping with that, or are they adding more almost more barriers because now there's the data regulations and aspects like that?
So yes to both, right? So I mean, you got to meet the organization where they're at and take them where they want to go. So if we think back, sure, there's regulations, there's security and all of the privacy, but I think it was Kevin was talking about the cloud, right? I mean, remember that transition when everybody wanted it on-prem for that it wasn't even the distance past, right? And now the cloud, and then now we're talking about Kevin's talk, the in the device, right? So yeah, there are barriers, but if we think about how far we've come and where we're going to go, it's too exciting to be a barrier. As far, you know what I mean? It's like.
Mm-hmm.
I love that idea. Too exciting to be a barrier, and that's the energy that we need.
Yes.
And maybe as we kind of close out this third section, before I do that, I want to hear about some case studies where the AI insights are maybe influencing the decision making in energy projects, whether that's how to build, what's needed. So what are some specific case studies that we can point to that show the possibilities?
And we've got some really exciting ones, right? Because now you have the data, you've built that infrastructure around, and your business is asking the questions. And to Scott's point, they've been asking those questions, right? But now they have the data and the visualization to point to it. And the people that aren't even the data stewards or the data experts can have the data conversations, right? Because they've been the boots on the ground. They know what it is. But now they have data to back it up. And some of that is in EV adoption. So we've built models around who's going to buy. So we all talked about it, where are the EVs? Where do we see that? Where do the chargers need to be, right? Well, we talk about that because we know who has a propensity to buy an EV, right? We know what they look like. We know the demographics around that person that's going to be those early adopters, right? So we have some machine learning models built around that are pretty exciting. And that was maybe one of the first ones that was a little on the edge, but no pun intended, but a little more ahead of the game. But then there was also, so now we started looking at EVs, and then some people are like, well, that's great, but are my transformers going to be overloaded, right? It's like, well, that's a great concern. So now we brought in data to see, okay, if I add one EV to that transformer, if I add two EVs, so where is that tipping point? When is it going to be overloaded? What can that transformer hold? And, is it already overloaded? So models like that are working, and, you have these dashboards and everybody is talking, and that's the excitement, right? Everybody's bringing their best self to the conversation, and the data is driving that. So that's what I see.
We have a partner that we work with that's in doing stuff on the side of the substations, and they've started implementing AI. And and as I said, we're at the very beginning of this, so the conversation is different next year. But initially, it's a 20% reduction in cost for operation expenses that AI is as a benefit to them. The other one is that as they're taking in the data and they start working the models, now they're getting 95% accuracy in condition-based monitoring, and they're within the model that they're seeing is 90% being able to predict failures a week out with the accuracy of 90%. So this is all in the very beginning. So the more data that they take in, the more sites that substations that they bring online with this technology, they see it going from 90% to 95 to 98, to eventually 100% accuracy, right? Or 99, right? Because there's always going to be the act of God that you can't predict, at a certain failure time. But, in a normal operations, they will predict, 99% of the time. So we're seeing it, and, things will be more exciting, Matt, when we have this conversation next year, the second anniversary of this group getting online.
Absolutely. I love that. And Jignesh, are you seeing any of those real world examples that mirror what we're hearing this conversation from the Saviant side?
Yeah, I have, when I was hearing Carol, there was so much deja vu in my head. So at Saviant, we have maturity model of data, not just data, people maturity as well, organization maturity, system maturity, which collects the data, right? And that's how the success rate is. Every organization is at certain maturity level when they start that journey, when they want to get into the next maturity level. Every organization has to spend some time at certain maturity to move to the different maturity. And it's not just as we discussed, not just data, it's people maturity as well, how they are using, how they are visualizing the data, what action they are going to perform, what KPIs or insights they are interpreting in a different way. So it's a more on a maturity which of other than data, people as well as organization maturity, system, data maturity, a lot of experts can work on. People and organization maturity, it comes with certain behavior changes, and it's a human nature. So I can really understand customers. Maybe in the first couple of months, they say that we are here, we don't have systems, data collection automated, but we want to be within 6 months, we want to have a ML model. It doesn't happen. It takes time. Maturity takes time to build. And we have seen over the period of time a lot of companies who has started at certain maturity has taken the steps in the right direction to collect the data, automated data systems, cleansing of data, creating that the reporting grade data, which goes through the multiple cycles of maturity as well. And there are a lot of organizations who have succeeded into going from maybe maturity 1 to maybe the highest level, which is level 5, which we like to call the prospective modules. And it takes time, and the use cases are everywhere. The use cases are not just in energy, but all the industries. In energy, we have one of our customer. We've been working from some time now. They are an energy accounting and consulting firm. So they have to have the edge when it comes to suggest or advise to their customer, collecting data from so many data sources. And then they are from Australia, so they have net zero targets as well, sustainability targets, right? So their customers are demanding, their customers has to meet regulatory and compliance challenges as well. And hence the data is paraphrasing, has to be the gold standard when they can predict certain things, when they can predict and meet the benchmarks which they have set for internal as well as government standards. So completely agree. There are a lot of interesting, and then obviously machine learning will come in the picture when you have the data, when you have the correct data, And there are so many fancy things are there in terms of models, but I think it might take the entire session just to discuss the machine learning models. But the maturity is the most important in terms of data maturity, systems maturity, organization, and people maturity to get the right results for whoever is working on those data, who is viewing the data, who is absorbing the data. Adoption is the key. If it has to be successful, the investments has to be successful.
Yeah, absolutely. That's well said, and I think a good bow on that section. And now we get to move on to our final one, which is exciting because it's the most forward-looking. And I want to talk about AI in energy innovation and R&D. And so, Kevin, I do want to start with you on here. What are some of the most prominent trends shaping AI's role in today's energy research and development that you're seeing and that you're working on from that data scientist side?
There are several prominent trends nowadays in different industries that are working on, but I think that the more important, I would say, it will be like predicting electricity demand on managing the grid loads, right? Because we have these vast amounts of data, and by analyzing this data, we can create models that can predict, or we can anticipate the demand surges and drops, and we can, with this information, with these predictions, help the grid operators to manage the grid system, right? To stabilize, right? So another important trend, it will be the integration of renewable energy systems or energy sources, sorry, because as we are we transitioning right now to a lower carbon energy future, right? Integrating these renewable sources into the grid is essential. So, but we have many challenges, right? We have the solar energy, the wind energy, for example. The sun doesn't always shine and the wind doesn't always blow. So we don't have like continuously power generation. So we use AI to generate forecast models to predict where are going to be the peaks of generation of energy, right? And with this, we can help the utilities or the grids to integrate this energy to prevent blackouts, for example. Yeah. Another, but well, the last but no less important is the predictive maintenance, right? Because we have right now we can have the monitoring and the maintenance of the infrastructure of the utilities in real time. We can use sensors data to create models to predict when we have to give maintenance to a transformer, for example. And with this, we can prevent outages, or we can increase the lifespan of the infrastructure. I think these are the most important trends that we're working right now. Yeah.
Excellent. No, I think that's definitely some great starting points, and I want to dig deeper and hear from the rest of the group about maybe if we look at the energy management solution side, what are some of the AI powered tools that are being developed, being put out there that you think are going to have the greatest impact, that have had the greatest impact thus far, or will have the greatest impact when they roll up at scale?
Definitely the demand energy prediction, because with this you can predict when are going to be the peaks of demand in the energy, and this can help the infrastructure of utilities to prevent the blackouts. For example, in Latin American countries, you have problems in infrastructure of utilities, and right now they are implementing this prediction of demands to help to stabilize the grid, right? To prevent all these outages, right? Yeah, I definitely think that electricity demand prediction is the most important, so far, yeah.
Yeah, always go back to my professor in school who used to say the best things to work on are basically things that were published back in the 60s or 70s that did not have the compute power to simulate. That's the lowest hanging fruit for you to go and figure out right now, because you have compute power to actually simulate it. I think one of the biggest advantages of having machine learning, AI, and the compute associated with that is you can simulate a ton of what-if scenarios beyond what's known today, be it materials, be it some kind of exquisite chemistry that needs to come up, that needs to play, be it fault detection, be it manufacturing in general, how you can cut down costs, how you can actually find out probably a more reliable raw material, how you can malleable that into the product. So all that you can create digital twins, and you can just feed significant amount of data to do R&D basically. So rather than spending tens of billions on actual material science R&D, right, for manufacturing, you could do that all through AI. So I think that's one of the key takeaways for me on what it's allowing R&D in different areas to actually perform today.
Mm-hmm.
Yeah, I think the low hanging fruit is a great way to put that, and it's not new problems that we weren't aware of. It was just we didn't have the tools to do it. So Kevin, you already mentioned sort of the demand side, and I wonder if maybe anyone else wanted to dig into more of the grid management side of not on an individual level, but on the grid wide level, how AI is helping to solve making sure we have the right amount of energy, the right place at the right time. What are some of the emerging tools that maybe people who are listening in aren't aware of yet that can be transformative in this way?
I was just going to say, part of that, I mean, we're looking at it, for grid resiliency, as we got into the battery storage and how to use that correctly, to do, peak shaving, et cetera, for that. But there's also a need, how do you implement AI into a brownfield, right? You can't just go out there and rip everything out and put everything in new with, AI. So, there's initiative on the hardware guys like myself to have solutions that complement, brownfield infrastructure today. It's not going to give them, the full benefit of, just a greenfield brand new application, but we are implementing ways that you can start adding AI to collect, from a brownfield, type deployment, a legacy infrastructure, to give that data to, people like Carol that can, crunch through it, generate it, we put it on a dashboard and then we can move forward with it.
And I'm wondering, what about also on the the product development side? Maybe that's something that Jignesh can talk to. How AI is evolving in those processes as well.
Yeah, AI is definitely helping on the product development as well as creating the faster turnaround times. There are multiple use cases which we have working on energy and utilities sector, where advancements in AI plus digital twin of products, digital twin of machines, digital twin of network, is helping to figure out the what if scenarios, as Swaraj rightly mentioned, and it helps immensely in terms of performance optimization, reducing downtime prediction. It also helps in terms of regulatory and compliance in some of the more sensitive, like oil and gas pipeline networks, right? It definitely helps in regulatory and compliance reporting, as well as being above the benchmark. There has always been use cases in terms of, let's say, wind turbines, gas turbine, digital twin, furnace digital twins in multiple manufacturing as well as energy and utility space. So digital twin plus some of the models helping realize the value faster, realize the cost effectiveness. I think those are some of the biggest benefits, which is attracting investments. which gives much more predictability of success at a lower cost. I think those, and hence there is a lot of investment in innovation, R&D, right? There is so many new solutions being worked upon on this space at this point, which was considered a little bit behind in terms of hardware as well as software advancements. So now there is a lot of opportunities available in this sector.
I'd say the advancement of AI embedded cameras, right? We're seeing a big push into oil and gas and the monitoring
Absolutely.
of oil rigs with, cameras all the way around and three-dimensional 3D imaging, and then you start putting in heat detection and sound, and now you have right there at the edge, the ability to do all sorts of predictive analysis and maintenance and condition-based monitoring right there on the spot. You start collecting data and processing it right there inside the camera.
Structural integrity is one of the hot topics right now with on the spot structural integrity detection as well as analysis of this high value oil rigs. There are so many moving parts in oil rigs,
Yep.
so it makes sense to have a lot of investment, and then obviously provide those at a lower level as well to the end customer, to the end user, the benefits of it. Great point on that.
Yeah, no, that's a terrific point, and I see we're right up at the hour, so that's gonna be a great point for us to end today's conversation on. I want to thank each and every one of our panelists for sharing your expertise and insights today. It's been a really fun, informative session. I know our audience will take away some really valuable insights and perspectives on how AI and machine learning is already shaping energy and will continue to do so in the future. So thank you once again for everyone for engaging in today's conversation. And we definitely hope to continue exploring these topics in future discussions and events. So if you have any follow-up questions or would like to connect with any of our panelists, please feel free to reach out after the session and we'll connect you there. But with that, that concludes our session. So have a great day, and thank you all for being a part of today's event.
Thank you.
Thanks.
Thank you.
Thanks, Matt. Thanks,
Thank you.
everyone.